So yeah, as you tell, my topic is about algorithmic nudges, and a special application is adaptive social marketing. And I would like to thanks really the previous speaker, because it's kind of introduced already my topic, so I'm really happy with that. It will be faster. So yeah, I will just start a bit with the vision of the centers that I'm working with, and what we are trying to do. So basically, we're trying to tackle these big challenges. How to reduce energy demand in the low-tension residential consumer segment, or how to change the mode of transportation to work. For example, Bangalore in Electronic City would like they take more the bus than the car and so on. And I think there is plenty of economists here, and they know the classical approaches would be price or education, right? But what we know is using price is pretty hard, and politically will be really hard. So you can just look at the events that happen in France. So they've tried to increase a bit the price of petrol, and there were huge strikes and so on. So prices is not always the best policy and can take time. And same for education. On the short term, you will not see any effect. So people came up in economy, especially in behavioral economy, with psychological incentive, right? So what we call nudges. And I think the main understanding of my work is, the main goal of my work is understand and design nudges. But of course, as a theoretician, I will not do psychological experiment, I will try to model them using mathematical tool. And the challenge that I'm trying to tackle is how to use computer science, machine learning, operation research, and what we know in communication system to improve efficiency on the short term, long term of all these nudges, and also the implementation at the scale of a state of a country. So let me try to explain you a bit the ecosystem there. So assuming that you have nudges that you apply to people, right? And so let me see, yes. And you apply to these people, and these people are interacting with an environment. And if you want to do that at the scale of a city, for example, Bangalore, what is happening is this environment is unobserved, right? You just observe through some outputs, perhaps some sensors, camera, survey, air quality sensors, but this is all noisy measurement. But perhaps what you can do is take this measurement, use it, and using algorithm from game theory and online machine learning to do kind of a loop, you know? Like in robotic, a closed loop, such that at each time you use these outputs and you try to improve the nudges, and you hope that at the end, for example, everyone will take the bus to go in Electronic City. I've put two kind of red flags there. So first of all, because it's nudges and psychological incentive, it's really important to design a system where you have designers that can control what came out of the algorithm, else it can be extremely dangerous. And also, one of the things in nudges is people will not be forced to follow the nudges. It's not like a price or taxes where you have to just pay the fee, right? So people will be extremely keen on privacy issue, unfair algorithm, and so on, and you will have to deal with all these questions. And I think when you try to solve this kind of closed loop, and this is a tools that I'm working, the different questions that I'm trying to solve with the different mathematical tools associated to it, you have to solve this kind of three questions. The first one is how to design incentives. The second one is how to improve the quality of sensor networks, and also respecting privacy, and especially ask yourself, what is the quantity of information that I need from my system to be able to really improve the behavior of people, and then kind of doing this, finishing this loop, and how to adapt incentives in real time. And today I will talk about my work on the third point, how to adapt incentive in real time for specific nudges on social marketing. So this work has been done with people from IIT Bombay, Vivek Borkar, for the ones that I know him. And so here's the problem. So assuming that you have kind of a social network, and exactly as you said, you have some opinion. Each agent have an opinion of whether or not they should take the car, the bus, what is better, because there is also huge, especially, for example, in India, you have a huge stigma of taking the bus because people prefer to have a car because you show how much you can be powerful. At least it is there in some studies. And here's the intensity of the link of how much you trust these people in their opinion and so on. And you are kind of a controller that have a budget, and what you will try to do is just to influence some people in the social network such that they will take the bus, and you hope that just by imitation of opinion, you will drive to the system with a better state, okay? So, yes, so in reality, you cannot do that. For example, you have shown us this beautiful network in your village when you ask everyone who people trust and so on, but in reality, if you want to do at a large scale, you don't observe at all that, right? You don't have all this information to perform that, except if you are Facebook and Google, but then we are not, and also we don't want to be, we want to do with less information, okay? So what is a classical scenario? Perhaps you observe at time one communication between this guy and this guy. Perhaps at another time, and you apply this policy where you try to influence these three people. And perhaps at time two, you will try to influence these people, and you observe the communication between these people and these people, and so on and so forth. And perhaps another scenario is people only agree, only these three people agree to share the information. And the rest, for example, they have an app, and we can track what is happening with an app, but with the rest of these people, we don't know what is happening. So how can we deal with this partial information, and how can we still be able to perform our optimization problem, which is our social marketing strategy, okay? And so we will use tools from reinforcement learning, and for the people that know in physics, stochastic approximation and so on. So we'll present a really simple model, but please trust me when I say that it's also easy to generalize. We choose a simple kind of linear adoption opinion model to start with, but just for the sake of simplicity. So you have a finite graph with a finite set of agents, and they are communicating with each other according to a given probability Pij, where Pij is just saying that if I want to take an opinion from my neighborhood with probability Pij, I will ask to agent j, okay? And each agent has a valuation, which is his opinion concerning a given topic, and to simplify everything, we will just say that it's between 0 and 1, and we have opinion at time k, okay? And we assume that our graph, our set of agents, is divided in 3 sets. So the first set is the stubborn agents. They never change opinion, and they will always have an opinion hi. The second one are the uncontrolled agents, okay? They are the ones that evolve according to a Gaussian mechanism, but you cannot influence them. Means that they will be influenced only by the people in the network, but as a controller, if I send them an advertisement, they will say, no, I'm not interested in that, okay? And how the Gaussian mechanism is working, extremely simple mechanism for now, is you have an opinion at time k, you observe your neighborhood, and with some probability PIL, you will just take the opinion of L, okay? And now I will move to the last set of agents, the ones that we can direct. Oh yeah, extremely simple model. So if you want, you can put nonlinear, whatever. You will see that the only thing what I really need is a stochastic update. And in this case, unicity of the equilibrium where you converge. If you start converging to multiple equilibrium, depending on the trajectory or depending on this initial state, right now, I don't know how to do it, okay? So for, like, in general, with data, or in my context, in an online scenario? Stochastic model. For now, I'm saying this is just how, let's say it's how much I trust you. But the summation over L is equal to 1. Okay. And how I can influence people? First one, I just said advertisement, or I talk to you regularly saying, take the bus, it's better, take the bus, it's better. Or I basically pay people. So for example, I guess this is what is happening with movie stars and so on. I tell them, you have to show that you have adopted the bus and you have stopped taking the car, okay? And now I will move to the last set of agents. So of course, what is happening to the last set of agents? I can influence them, and they are still susceptible to the other network, right? They can be influenced by the rest of the network. And we just, alpha I is just capturing how much you are influenced by the controller, and how minus alpha is how much you care about the opinion in the social network. And then as you have a simple stochastic linear dynamic model, and depending on which set you are belonging to, you have different updates, okay? And what we are looking at in this case is the asymptotic regime, where we look at when the number of iteration of opinion exchange is going to infinity, and we're looking at this expected number, and you can easily prove that is the solution of this linear system, okay? And now what is our optimization problem as a controller? I want to maximize the opinion towards one. It's just, we say that one is taking the best, subject to this equilibrium constraint, okay? So U is my control, is basically how much money I invest, or how much time I invest in an agent. So U is appearing here, but of course I have a final budget, and I'm trying to solve this optimization problem. Okay, so right now I didn't say anything about the fact that I don't know the network, but do you have any idea, I would like, about how to solve this optimization problem under constraint, equilibrium constraints? Any of you? So when you do convex optimization, what you usually do? You compute the gradient, right? So the only thing that you have to do here is to find a way to compute the gradient. It's a linear system. So the only thing that I have to do is to compute the partial derivative of the opinion on I when I invest on J. And because I have a linear system equation, I can prove that my partial derivative is just the solution of a linear system. Okay? And therefore, I just write the Kakati condition, and I just say I have to find the fixed point of these equations, where this is determined by a linear system, and I'm good. And one way to find this fixed point is just to performing a gradient algorithm, okay? So let me try to explain a bit how to compute my gradient, solution of a linear system, then to find the optimal strategy, the optimal targeting is just gradient algorithm, okay? So now the question is, PIL is not known. I don't know my social network. I will just observe sample over time of it. So what should I do with it? So let's assume that my observations are as follow. At each time, an agent will active himself and will change his opinion. How will he change his opinion? He will see with probability PIL, if I'm agent high, your opinion. For example, I will just ask, what is your opinion? And I will take mine. And I will observe this realization, okay? This sample realization. So now I know that I observe basically some sample distribution of PIL. So you will tell me, so one simple solution of this problem is simply just wait enough, and you will observe the graph, and then apply your strategy. But we know that one of the talk of yesterday was saying that the environment is changing a lot, especially concerning this issue, perhaps connection can change, and so on. So you want to do an algorithm even with the first sample, because you hope that already you don't have to wait too much for your targeting, because perhaps when you will estimate your social network, especially for in big city like Bangalore, when people switch jobs so often and so on, perhaps your social network will change really fast and you will have to find a new strategy and so on. So you cannot just wait to have enough sample to start with. Okay, so luckily enough, in reinforcement learning and all this robotic and so on, we are able to deal and stochastic approximation, we know how to design some approximation of function with simple and averaging. So what we just say is the following. The partial derivative at time k of the opinion of agent I when concerning the fact that I'm infecting agent J will be equal to the previous valuation. If agent I is not active, everything is equal to 0, so I'm not updating my process. So I will just say that the partial derivative is still the same. And if agent I is active, so here you have some terms such that you are converging, and then I'm just saying that it will be equal to the probability to be infected externally plus the probability that I've observed a communication, which is the realization of this process, minus the previous derivative, okay? And if you take this equation in expectation, what you're able to prove is that in expectation, this is exactly an iterative procedure to estimate this equation. And you know that when k will converge, when k is growing to infinity, you will converge to the true gradient, okay? So now I just give you a procedure, a decentralized scheme, that when k is going to infinity, will converge to the gradient, okay? But how to couple that with now my strategy, my targeting strategy in the social network? The thing is perhaps if I use a certain strategy, I will perturbate the learning, right? So for people that are familiar with this kind of scheme, what we do is we do 2-time scale. We say that we approximate extremely fast the gradient, and we slow down the trajectory of the gradient algorithm such that it's nearly equal to 0, and the speed compared to the other one is nearly equal to 0, and in such a way that I will not perturbate the learning of the gradient, okay? So here is some simulation results where basically this is the optimal strategy, this is a certain number of iteration, and here is basically, I would say, here's learning phase of the gradient, and then after some iteration, you start to see the convergence of the algorithm. So I'm sorry to see, so what you see is just a methodology, extremely crude methodology, and of course you can improve the speed because 40,000 iteration means that you need 40,000 iteration to have some decent result. But of course, if you add more knowledge and so on, we can increase the speed. So, but it was not the purpose here. Sorry? No, yeah, you can. You can because we have a decreasing time step. So this is the technique in stochastic approximation. We have 1 divided by n plus k plus 1. So you know that at some point with probability 1, you will converge to the mean. So it's not, I think in your case, perhaps you always have a constant time step, so you are not converging. In our case, we are forcing the convergence. But the problem is getting slower, okay? So just to summarize, using a methodology come from CS and machine learning, we have a solution of adapted social targeting problem, where we use a 2-time scale algorithm, where at the fast time scale, we have an estimation scheme of the gradient, and at the slow time scale, we simply solve the gradient algorithm for choosing our best targeting strategy. And about the extension is, I just give you one observation scheme, where basically we observe communication of agent at each round. But perhaps we can imagine something else where I just observe a realization of the opinion. Perhaps I can imagine something when I target someone, then I will ask a question, who is your neighbors? And so on. And depending on what is more realistic, in this case, you can design more scheme, but using always this kind of technique, I guess. Is it possible to apply this kind of model in transportation and energy efficiency? So we are working on that now. Also, there is a question of in which set of agents I should invest to get more information. You know, it's more about, you have always a trade-off of there is perhaps agents that I should infect, and they have agents that will give me more information about the social network. how to design an algorithm to do that. Then there is more economic question, for example, prices scheme. You can imagine that people will not give you any data and so on. And yeah, and also all these other questions. So yeah, that's it.